Good morning, good afternoon, and good evening, everyone. Welcome to this joint GTAP-UNDP webinar to provide consultation on the 2026 Human Development Report, Reimagining Human-Nature Relationships. The 2026 Human Development Report will explore what human development progress looks like in a world where planetary systems are increasingly under strain. It will introduce novel data, and this consultation will present the latest thinking of the 2026 HDR with a special focus on two metrics, a multi-hazards index and a new proposed nature relationship index. For this webinar, we have three speakers. The first one is Dr. Pedro Conceição. He is the director of the Human Development Report Office at the UNDP since January 2019. Prior to that, he was Director for Strategic Policy, Chief Economist for Africa, and Director of the Office of Development Studies, also at UNDP. He has published widely on financing for development inequality, global public goods, economics of innovation, and technological change and development in several journals and books. He was remarkably the lead author of 5 previous human development reports for 2019, 2020, 21, 22, 23, 24, and 2025. In preparation for this 2026 HDR, he co-authored a perspective published in Nature in 2025 entitled An Inspirational Approach to Planetary Futures. Prior to coming to UNDP, he taught at the University of Lisbon, and he obtained his PhD from the University of Texas, Austin, under a Fulbright scholarship. After Pedro, our second speaker is Dr. Nick Depsky. Nick is a climate scientist with experience in hazard modeling, impact evaluation, and adaptation policy. His past research has focused on assessing drought in Central America, evaluating global sea level rise, and assessing climate-induced human migration. He has directly supported environmental justice in California and carbon pricing at the federal level. Nick has worked in Latin America with local governments and stakeholders to provide modeling support for watershed management and climate adaptation. He obtained his PhD from UC Berkeley's Energy and Resources Group. And then finally, our last speaker for today is Professor Ellis. Erle is Professor of Geography and Environmental System at University of Maryland, Baltimore County. And he is a highly cited global researcher studying global ecology of human landscapes and in the Anthropocene. He teaches environmental science and landscape ecology at UMBC and has taught at Harvard's Graduate School of Design. Among others, he is an author of the IPBES Transformative Change Assessment, a fellow of the Global Land Grant Program, and a senior fellow at Breakthrough Institute and former Anthropocene Working Group member. He was also, he is a visiting fellow at Oxford's Martin School. In 2019, he published Anthropocene, a very short introduction in 2018. Well, welcome everyone, and I turn it over to Pedro for a brief introduction of the 2026 HDR. Pedro, over to you.
Thanks so much, Erwin. Good to be with all of you. We will do 2 deep dives, as Erwin mentioned, and I just wanted to provide a little bit of context about the work we're doing in our office that sort of sets the stage for the explorations that we're doing leading up to the 2026 Human Development Report. So human development is something that's been around for quite some time. Human development reports started 35 years ago in 1990. And I think it's perhaps fair to say that the focus was very much on people and proposing a way of understanding development progress and assessing development policies in ways that considered obviously the performance of the economy and income, but went beyond that and had this broader idea that human development is really about expanding opportunities, capabilities for people. So income is important, but also achievements in health and education also matter. And along with this idea, the office is known for putting out there a number of metrics, indices connected with this human development approach. So these include the Human Development Index, the Multidimensional Poverty Index, some gender indices. And I think that's sort of the core or has been the core of the work in the Human Development Report for many years. Now, more recently, we've tried to understand the extent to which the fact that our planet is changing very rapidly, sometimes described as the Anthropocene, as a new reality, how that is already shaping prospects for human development today, but perhaps more importantly, how is it likely to shape prospects for human development into the future. And we perhaps started looking at this more systematically with the 2020 Human Development Report, in which we introduced a new metric that we called the Planetary Pressures Adjusted Human Development Index. And since then, we've been continuously trying to provide more data, information on how, again, prospects for human development are affected by planetary change. So one example of this is something that we call Human Climate Horizons, which is a platform that links some climate hazards like temperature and sea level rise to outcomes that matter for human development, mortality rates, labor supply, energy consumption. And just 2 weeks ago or so, we updated the platform to provide estimates on agricultural yields. So I'll put some of these resources on the chat. I know it's a lot of information to absorb, but I just wanted to give you a sense of some of the things that we have been doing about understanding how human development and planetary change interact. The other thing I will mention is a report that we launched a month ago or so on multidimensional poverty. This is something that we've been doing over the last few years. Every year we launch a multidimensional poverty index report with a different focus. And the focus this year was on how poverty and climate hazards often overlap already and are likely to be even more tightly connected going into the future. So it's in this context of this exploration that we are in the 2026 Human Development Report trying to supplement current framings of environmental and sustainability challenges that are premised on the idea that we confront a crisis, and that's the driving force for public mobilization and political action to address the challenges. So narratives premised around the idea that we face limits or boundaries have been very influential. And our assumption, hypothesis is that it's important to supplement this kind of framings with an approach that, as you mentioned, Erin, is a bit more aspirational, right? That was the title of this nature perspective that I co-authored with Erle, Nick, and others. And so to do that, we are trying to explore different concepts that could speak to this more aspirational approach. But in the tradition of our office, we don't want to stay at the level of abstract concepts. We want to see if we can link these concepts with metrics, with indicators, with numbers that would enable us to see if we are moving in the right direction. So with that, let me pass back to you, Erwin. And as I mentioned, I'll put some of the things that I mentioned on the chat so that colleagues have some resources to go to related to some of the things that I mentioned. Thank you.
Okay, thank you, Pedro. And now we turn over to Nick. Nick, if you could kindly share your screen, please, and then
Sure thing. Yeah. Um, Great. Can folks see these slides on your end?
yes,
Perfect.
thank you.
Okay, great. Well, yeah, it's good to be here. Thanks for the nice introduction. And yeah, so I'm gonna dive in to discuss the first of the two new indices that were mentioned for the 2026 Human Development Report, or HDR. And so this one pertains to creating a multi-objective climate hazard index. And the overlying motivation for this exercise, or this initiative, is rooted in concepts that we discussed in the 2020 Human Development Report, as Pedro alluded to. And this is a figure from that report, which shows the sort of interconnected balance of different planetary and social imbalances, and how those are impacted, and there's interplay with planetary shocks, inequalities, pressures, and risks. And the planetary pressures adjusted in Human Development Index, or the PHDI, which Pedro also mentioned in that 2020 report, focused primarily on understanding the dynamics between pressures that humans place on the environment and the climate, and then how those correlate or track and are related to inequalities. But this new index that we're developing for the 2026 report is meant to sort of fill in the conceptual gap and capture the different aspects of the remaining part of this cycle, where we've started to quantify how different countries have disparate levels of impacts in terms of CO2 emissions per capita and things like that on the environment itself. But we haven't yet formally developed a metric that measures um, how those pressures are then manifested in hazards to human well-being, security, and development itself. Um, hence this environmental climatic hazard index that we're making. So again, it's sort of rooted in a conceptual framework that folks might be familiar with from kind of the IPCC concept on human risk as it relates to hazards and exposure and vulnerability. Maybe you've heard definitions of vulnerability as being sort of products of exposure, sensitivity, and adaptive capacity, and things like that. For this metric, we're focusing primarily on exposure, just physical exposure to different climatic risks, and then eventually going to layer in additional layers of sensitivity and adaptive capacity and vulnerability as well, to kind of get a more comprehensive picture of human risk. Um, and so we're calling this the Multi-Objective Climate Hazards Index, or MOCHI. And one of the main value adds of this relative to previous indices that our office has developed is one that leverages the high spatial granularity of different climate and environmental data sets, which are at much finer gridded resolutions, whether they're products of global climate models or satellite imagery and things like that. A lot of these are produced and purveyed at much at resolutions which enable much finer than country level analyses. And so this Mochi index we are developing at multiple different spatial scales. The first of which is country level, state, province level, county, municipality level, or a uniform 20, kind of roughly 25 by 25 kilometer or quarter degree land grid. And we're doing this for historical climatology conditions. So looking at historical exposure from roughly the 90s through 2020, and then we'll also be expanding this to include future climate scenarios into the future with ensembles of climate models as well. What I'm presenting here is primarily just the historical exposure uh, rendition of this index. And I'll show some comparisons with other pre-existing indices as well. So here's a very simplified kind of graphic showing how we tend to think about the trade-off between developing an index that is maybe rigorous in the sense that it captures dozens and dozens of different environmental and climate hazards or metrics or contaminants and all these different things. But then the more complex and rigorous something might be, it tends to sort of then sacrifice its interpretability and simplicity. And so for the kind of flagship metric from our office, the Human Development Index, part of its power and part of its success over the decades is that it is very interpretable, but still captures three important human development outcomes in educational conditions, life expectancy, and incomes. And so our goal is to try to strike that sweet spot and develop an index that is meaningfully rigorous, but still interpretable. And so here's an example of all the possible kind of environmental and climatic indices that could be included in such an index. And in the spirit of maintaining interpretability, we're mostly just focusing on climate for now, although we will likely experiment with developing different iterations of this in the future. And so we selected 6 types of climate hazards that occur across the globe, and these are the 6 of them kind of from a 0 to 1 normalized relative magnitude scale for historical conditions from 1991 to 2020. And so the metrics we're looking at are relative drought severity, exposure to drought severity. And so that's the top left. The top right is exposure to riverine or coastal flooding. And then middle left, we have exposure to extreme heat events. Middle right, we have exposure to extreme precipitation events. And then lower left, we have exposure to tropical cyclones. And then lastly to sea level rise. And so these are country level maps, but as I mentioned, we have these data at finer resolution. So if we look at this at ADM 1, administrative level 1, so sort of state or province level, we get a slightly more disaggregated picture of where these relative hazards occur in each country. And then we can scale down further to admin level 2, so kind of like the county municipality, and then finally down to a quarter degree land grid. And when we combine the 6 of these together, similarly to how the HDI metric is an equally weighted combination of the educational, health, and per capita income measures, doing something similar here, where we combine the 6 of these into one metric. This is what we find. So the darker orange brown countries are those that have compound exposure to multiple of these 6 hazards at a high level. And then again, kind of going down the different spatial scales, we have, this is the country level, the ADM 1 level, the ADM 2, and then finally the quarter degree land grid. And so here you can start to see actually some of the patterns from things like the river drainage networks and coastal areas that experience multiple different types of hazards. And here's a zoom in at the administrative level 2 region for northern South America to just kind of give a sense of a little bit more close up to how these look regionally. And so for drought exposure, you can see that the kind of the eastern Amazonian basin, where there have been some pretty major droughts in cities like Sao Paulo, and then flooding much of the interior of the Amazon basin, which is exposed to riverine flooding, and then extreme heat throughout, with the exception of the sort of Andean Cordillera regions, and then similarly extreme precipitation throughout the Amazon basin, as well as on the Pacific side of the Andes. Tropical cyclones don't typically make it that far south, but then sea level rise, you can see that ribbon of orange along the coast there. And this is what the MOCHI index, or kind of combination of compound hazard exposure, looks like for that region at the ADM 2 level. Here's another regional zoom in that looks at these 6 hazards. Do have exposure to tropical cyclones in the lower left throughout the Indian Ocean basin and Southeast Asia, and basically the region where they're called typhoons and not hurricanes. And then what the MOCHI combined index looks like that for that region. And then lastly, here's one more regional zoom in on the kind of CONUS region of the US. And so as we may be slightly more familiar, we have kind of droughts out west. We have flooding, especially along the Missouri and Mississippi rivers, and then extreme heat exposure concentrated more in the south, and then extreme precipitation kind of in the southeast and parts of the Pacific Northwest, and then tropical cyclones throughout the Gulf Coast, and eastern seaboard, and then sea level rise accordingly, as well. And that's what all 6 of them combined into one metric looks like. And so we have kind of relative compound climate hazard exposure along US counties. So in the US, the ADM level 2 is at the county level. And so another aspect of this is that we have, so having the exposure to multiple climate hazards available is really helpful. But what especially in our office we'd really like to do is understand how the spatial patterns of this compound climate hazard exposure correlates or does not correlate or is related to the spatial distribution of other metrics of concern. So predominantly like the Human Development Index. And now, as I mentioned, the Human Development Index is traditionally just produced at the country level, which is true of the HDI that gets released in our reports. But our office has been undertaking some other research initiatives to leverage satellite imagery and machine learning techniques to actually produce downscaled predictions of HDI at a subnational level. And so this is in collaboration with some academic research colleagues in the Global Policy Lab at Stanford. And this has been developed a couple of years ago and I believe is being published shortly. And so what we see here is HDI being produced at the ADM2 and also at a tenth of a degree grid across the globe. And so this allows for a much higher spatial resolution comparison between other similarly granular metrics and the HDI. And so when we compare these, and I would sort of mostly pay attention to the right-hand column, which is the version of Mochi that I've been presenting, which is kind of a continuous scale. Rather than doing thresholded kind of binary exposures to each extreme. So each row looks at the different spatial scale of concern. So starting with the country level on the top row, and then going down to ADM1, ADM2, and then quarter degree land grid at the bottom. And so basically what we're looking at here is that on the x-axis, we have the multiple compound climate hazard exposure or MOCHI relative kind of from 0 to 1. And then similarly from 0 to 1 on the y-axis, we have HDI at the country level, which is the officially produced HDI metrics every year. And then at ADM 1, 2, and quarter degree grids. And so basically what we see here is that there's a correlation of lower HDI countries with higher compound climate hazard exposure. That's how we have this inverse correlation or sort of downward sloping trend line. And that trend holds at each spatial unit of sort of each spatial scale. And so this is anecdotally kind of what one would expect, that lower income countries are more exposed to climate hazards, but kind of crucially, this measure is literally just the physical exposure to multiple climate hazards and doesn't account for things like adaptive capacity and resilience and whatnot. And just shows that literal kind of spatial patterns of exposure are exposing lower income countries more severely. And so the kind of so what of this of developing a metric like this is meant to motivate kind of policy action and awareness, especially in the climate adaptation space. So this is a UNEP, a UN Environment Program report that came out last year, which analyzes the global adaptation gap for climate action, and specifically climate adaptation action. And what this report highlights is that globally, some of the biggest barriers and challenges to NAP, which is National Adaptation Plan, to NAP, National Adaptation Plan implementation. So some of the biggest barriers to those country adaptation plan implementations is informational. And so sort of having access to interpretable information about what types of climate hazards are likely to occur, where vulnerabilities are within their countries and different communities. And so we're hoping that this MOCHI index can help kind of bridge that informational gap. And this is that the gap in terms of financing and totals, kind of graphically explained. And some of the implementing partners currently of global adaptation finance, one of which is the Global Environment Facility, or GEF. They oversee kind of roughly in the neighborhood of $5 billion a year for country specific climate adaptation financing projects. And they have expressed an interest. They work with the UNDP closely, and they've expressed an interest in this metric to help them kind of evaluate the country profiles from a relative vulnerability standpoint, and then potentially inform their climate financing actions moving forward. So we're hoping that target audiences sort of like this, that operate at the interface of policymaking and climate science, are kind of our target impact arena. And so, as I mentioned, and as I've been showing, mostly just spatial exposure patterns to multiple compound climate hazards, but we're hoping also to eventually layer in other measures of human vulnerability to get a more comprehensive sense of overall human risk. So now this would take into account actually aspects of things like relative sensitivities or adaptive capacity to a given climate exposure to a given climate event or climate hazard. And so one possible layer is the Global Gridded Relative Deprivation Index that is produced by Columbia University, and that looks at relative high to low, kind of multiple household proxies of poverty mapping and things like that, where if you were to combine the exposure version of MOCHI with this GRDI metric, you could argue that you're closer to representing human risk. And so when we do that, this is now the same maps that I showed before. This is just exposure, the country level exposure, compound climate scores. But if we combine with the GRDI, so this is now kind of a risk version, we can see that a lot of countries now show more pronounced risk, and sort of in some of the lesser developed country regions that one might expect. And so then this is the same thing, but at ADM1 level. So this is just the exposure, but now this is exposure and vulnerability. At ADM2, this is just the exposure map I showed before, but then if you combine the two, you get a sort of altered pattern that integrates both exposure and relative vulnerability. And then at the land grid, we have exposure, and then with the vulnerability, and the land areas that are masked out here are basically areas that are sparsely populated and don't have human population. So I'll stop there. Since it looks like I'm right around 20 minutes. We are in the process of integrating future climate projections. As I mentioned, this is an example of some ensemble temperature projections just for the country of Brazil. And we've been working as well with some other country offices on developing some support for their National Human Development Report endeavors and whatnot. So there's a lot of work in progress, but I'll kind of pause there. Thanks.
Thank you, Nick, for being mindful of the time. If you have questions, please write them on the chat box, and then we will come back to it after Erle's presentation. We now move over to Erle, who will present measuring nature relationships. Erle.
Thank you, Erwin. And yeah, thank you for giving me this chance to talk about a project we've been working on for a couple of years. And this is something that's inspired by the idea that perhaps we need a little bit more of a message to the public than simply the crisis is getting worse. That seems to be the only message that the environmental community has been able to use to try to drive engagement to do something about the relationship we have with the rest of nature that is clearly not the one that we would choose. It's the unintended consequences of things like burning fossil fuels is causing severe harm, and that message is loud and clear. But we have to do a little bit more, I think, if we're going to truly try to engage people in doing something to produce a better future. It's not just about avoiding the harm. We have to have a message that talks about what we can do, how we can actually shape a better future. And so that was the general mission of this project that we called an aspirational approach to planetary futures. So the human development approach, in my perspective, and I think everyone here's perspective, is fundamentally an aspirational approach. It produces the belief and it maintains the belief that human societies can improve the conditions that support people, and that we can make progress when we work together to create social change for the better. That's underlying, that's the fundamental message of the human development approach, and the Human Development Index is ultimately a measure of this. And even before we have a Human Development Index, we have this record of really unbelievably powerful transformative change in the lives of people. Human societies have shaped conditions for people that have enabled people to live longer, have better access to education, and better standards of living than ever before imagined. It's really something that we should be proud of, and we should realize that when human societies embrace these aspirations for a better future and do something to create better conditions, they succeed. So what about something that's not necessarily the same as getting things that are better for people? So nature's contributions to people is the framework that's now used by the Intergovernmental Panel on Biodiversity and Ecosystem Services, this idea that nature contributes to people, okay? And that's the conventional view. Of course it's true, right? We couldn't do anything without using nature in various ways. People benefit from the use of nature. I think most of us should be familiar with the idea that human societies are very good at reshaping nature to provide services, capital, etc., resources for the human enterprise. But imagine this. Think about the relationship that we have with the rest of life on Earth. The relationship that, as Darwin put it, we're all related. All organisms on Earth are part of one big family. Now imagine if your role in the family was just to make sure that nature contributed enough to you, right? Being the taker only. Our interest here is trying to emphasize that, well, as members of the family of life, we need to give back. We need to have reciprocity. And so the ultimate question is, can human societies, can our aspirations for a better future that have reshaped the world for people, can we reshape the world for nature in such a way that nature will actually benefit from us? And the idea that this is some kind of radical new thing for human societies to shape nature in ways that benefit the rest of life is incorrect. Most human societies over most of human history have sustained over long periods the biodiversity that is now what we talk about conserving. The idea that the most biodiverse places are some place without people is incorrect. The most biodiverse places on Earth are places like this, these cultured ecosystems where human societies have a long history of shaping conditions that have sustained biodiversity, not the opposite. The idea that we don't have many, many different ways of sustaining healthy relationships with nature, relationships that give something back. This is from the paper in Nature, the Aspirational Approach to Planetary Futures. And this is just looking at some of these many different ways. And so that's the first part of the aspirational approach, is to shift that narrative. We're not just destroyers. People and societies are not just destroyers of nature. Human societies can have healthy relationships with nature, and we do. The idea, even at planetary scale with modern industrial societies, that we can't actually do something to improve conditions for the rest of life, that we can't take responsibility and change the game as we did, for example, with another atmospheric trace gas that would have made it such that if we had not controlled the production of CFCs, we would now be living in a world where going outside, you would get a sunburn in just 5 minutes or 10 minutes, some very, very different condition than the one we have now. Life is much better on Earth thanks to the action of people in controlling these things. The idea that we're not interested in bringing back nature. Well, the wolf is a very hard animal to live with, but because people want the wolf back in Europe, the wolf is thriving and returning all across Europe. It's not an easy animal to live with, but because people want it back, the wolf is back. So our cultures of nature, what we demand from nature, can be something that brings nature back in. The aspirations for nature have changed from something as simple as stop destroying nature, avoid destroying nature, to something that involves actually aspiring to a better future with nature, nature that recovers, nature that comes back. We even have that at the United Nations in general, this idea that now people have a human right to a healthy environment. These kinds of things are going on. So that's the kind of background for where we start the aspirational approach to planetary futures. So the idea is that human development and the capabilities approach and the HDI as a measure are all about measuring progress toward a better future for people. Well, in our view, we should expand the dimensions in which we view progress toward a better future to include our relationships with the rest of life on Earth. So we basically came up with and we model our approach on the Human Development Index. So we chose to use 3 dimensions of a healthy relationship with nature and a relationship that improves conditions for the rest of life. And those are the 3 dimensions we chose. The nature is thriving and accessible, nature is used with care and respect, and nature is safeguarded. And just like with the Human Development Index, this is to be computed using different indicators for each dimension. And the goal is to keep it simple, not too many indicators, a set of dimensions and an index that is something that can be comprehended readily by not just experts, but ideally by ordinary people could understand the basics of what constitutes this better relationship with nature. And the way we think about it is not necessarily as kind of embedded within the Human Development Index, but rather expanding the space for thinking about progress toward a better future in terms of a world where not only human development is advancing, but we also have improving relationships with the rest of life on Earth. And so that creates this kind of aspirational space in which we're not just looking at progress on the Human Development Index, but also on the Nature Relationship Index. And that little green arrow there represents what you'd call the aspirational direction. You want to be moving toward a world where you have better conditions for people and for the rest of life on Earth. Okay, so where are we at with developing the Nature Relationship Index? The paper, and I'll show it quickly, introduced a kind of test version of the Nature Relationship Index. We didn't consider it fit for purpose, but as good use for looking at how to identify the challenges and opportunities of developing the Nature Relationship Index. We developed a rubric for understanding how to choose indicators for the Nature Relationship Index. And this is also mostly in the publication. We haven't really changed it that much. And the version that we started with is this one. This is the example indicators we used in the conceptual model of an NRI in the nature perspective. And it includes the conservation of habitats in protected areas and other effective area-based conservation measures, OECMs, that's the land area conserved. Thriving landscapes, which is an indicator that measures the amount of habitat within the landscapes where people live and work. And when these landscapes have more than 20 to 25% of semi-natural or natural habitat, these landscapes are denoted as thriving, and the percent of a nation's landscapes in that category is the indicator thriving landscapes. Less carbon emissions per person, less agricultural land use per person for using with care. And then finally, nature is safeguarded with legal protections for nature using a kind of index approach. Okay, this, as I said, was not something we ended up going with in the long term, but it gives you an idea about where this was going. And you can see that one of the first things we learned is that it was possible, and it was, in this case, it was what we saw. The NRI and the HDI don't have to actually be correlated. And that's actually a very important thing, right? If there's different ways to have development and different ways to have positive nature relationships at the same time, that gives lots of opportunities to create that better future. Then our next phase of development was to reach out to the expert community, folks who work with sustainability indicators, to judge the kinds of indicators we might consider using in an actual NRI for release. Here we have basically a similar set, but we've changed things around a little bit. We changed our index of emissions to actually look at emissions produced per unit of HDI, so more aspirational than the previous one. The land use one's similar. And then we changed from legal protections to spending on environmental protections. And then we also added in a clean air and water indicator, mostly by popular demand, which, everybody wants clean air and water. And so that is the NRI that we tested in this global expert consultation. And you can see it also doesn't have a strong correlation, although it's a little stronger between NRI and HDI. A lot of places where we didn't have data as well. Just a brief note about the expert consultation. We have almost 210 contributions from experts around the world representing 53 different nations. But it was mostly environmental science, and it was very biased toward the usual suspects, right? The wealthier nations of the world tend to get involved in these things more. But we had a lot of buy-in and a lot of indicators proposed as a result. We looked at the judgments in terms of communication and how well an indicator represents an aspiration for a better future, these sorts of things. And we're using that to develop the next level of NRI. And this is the current simplified NRI. I don't think this one is final either, but it represents a strong move in the right direction. You can see mostly we reduced some things. We removed the agricultural land use per person. That one just never was done right in a way that we felt we could defend. Anyway, and then that one also is a little bit better in terms of coverage, although still missing some places, a little better in terms of its relationship with HDI. And right now we're still in this final stage. We have a couple more, I'll show you a couple more indicators that we're taking very seriously and may end up in the NRIs. We're going to test a set of NRIs, but we did learn some very basic things, is that we really need to focus in on the concept of what would the Human Development Index do when we consider indicators. And that means we really need to focus on outcomes, not perceptions, not investments, not laws, but the actual outcomes. And that the challenges really are with the global data availability at this stage, if we're going to produce this on the schedule for release in May of next year. The two other indicators that are getting a lot of consideration now, percent clean energy is still a possibility. This would go under the used with care and respect dimension, and the same with the deforestation-free consumption. And this is something, as Nick mentioned or just told me, is something that's also produced using GTAP data. So you probably find that interesting. The amount of deforestation-free consumption is another indicator. Some of the other ones that we'd like to use they just have too many problems with them to actually use them successfully at this time, although we hope that maybe very shortly we could use them. But the bottom line is this framework for thinking of another way to look at and expand the dimensions of what it means to have a better future, what progress means in terms of an indicator approach. And our goal is hopefully, and I think we're still on target for this, to actually have this produced and ready to release for the 2026 Human Development Report. All right, thank you. That's all I wanted to say, and I have more slides if people want to go over any of the indicators in detail, but I think this is where we should stop.
Thank you so much, Earl, Nick, and Pedro for this amazing and very refreshing work. We now open the floor to questions, reactions, and I see that Tom has a question. Tom, do you want to unmute?
Sure. A question for Pedro and a question for Earl. Pedro, how receptive are you finding a receptive audience outside of the ecological environmental community? We've been hearing a lot lately from central banks. Say Central Bank of Chile is very interested in quantifying financial exposure to natural capital risk. Is there an audience there? Are you finding receptive ears?
Shall I respond, Erwin?
Yes, please.
I think you should start, Pedro, for sure.
Okay.
Yes, please.
Thanks, Tom. That's a great question. So the conversation we're having today is a conversation that we've been having with many other stakeholders. So in September, Earl was here and made a similar presentation to people in firms. So not only in the financial sector, but across a range of firms. And more on the side of regulators, I guess, if that's the question, central banks. And there was someone participating in that meeting that has been leading something called the Task Force on Nature Disclosure, which is something similar to the initiative led by Mark Carney when he was governor of the Bank of England on having a task force on disclosure of climate risks. Which is now something that is well established. So we've been having a dialogue with this community, and there's a lot of interest. There's also a lot of work, as Earl alluded to in his presentation, on sort of the nature positive framing. So how can nature help economies? How to account for natural capital in the balance sheet of firms? And I would say that all of that work connects with the NRI, and there's maybe some overlap, but it's sort of complementary, right? The NRI is not meant to replace this kind of effort. And in fact, in the report, we aim at having a chapter that looks into more the economics of nature, things like wealth accounting, the work of Partha Dasgupta and others. And we've been working with Eli Fenihel, who is an environmental economist at Yale, to help us to think through those issues. So I would say that there is receptivity, but one of the challenges, and maybe in this conversation we can dig into it a little bit. One of the questions we've been posed is, what do we do with something like this, right? So, okay, we put the NRI out there. What sort of the message for central banks or for finance ministers or for policymakers? So that link between the index and the policy action is something that we may not be able to fully specify. It probably doesn't make sense, but I think we need to have some theory as to how policy choices will enable us to move the needle on the NRI. So that's another possible way of getting people interested from those communities interested in the NRI. I don't know if this is a good response to your question, Tom.
No, that's helpful. Yeah.
I'd add on there in terms of how we're constructing the Nature Relationship Index, especially in terms of some of the indicators. Some of these indicators are already part of international policy agreements. For example, the conserved landscapes, the habitat conserved indicator is very much the same as the CBD's target for 30 by 30. Just we don't have a target where the aspiration is to improve the space available for the rest of life. So that's one example. The other relating to emissions is also an indicator of progress toward reducing emissions. And so these things actually fit into existing frameworks very easily. in terms of measuring progress toward a better outcome. They're just not based on targets. They're based on continuous numbers that add up to a better future. So I think they're just, in some ways, it's just a different way of looking at how we gauge progress, whether it, the classic thing is, have we achieved the target way is very limited. It hasn't proved very successful. I think 1.5 degrees is the classic example. And I think the idea that we can make progress generally and continuously, and we need to, every little bit counts, is the message I think that is very important to embrace in the longer term.
Okay. Thank you, Earl. Tom, you have a follow-up question to
Yeah,
Earl?
just Earl, as you were presenting, and Nick earlier on, I mean, this obviously working closely with the climate science group to develop the MUCHI. The Natural Capital Project has all of these 35 invest models for looking at ecosystem services. I don't know whether you're teaming up with them at all or envision a collaboration there. We've worked some with them. The GTAP community is working with the NatCap community somewhat on that, but I would think that's a group that is doing global gridded analysis of ecosystem services. I just wondered whether you were partnering with them. Maybe I missed something there. Nick, maybe you want to, I don't know who wants to respond to that.
Yeah, no, thanks. That's a good question. We haven't been working with the invest folks directly, but we've evaluated a lot of these kind of gridded, whether it's the NatCap stuff or other layers for both the MOCHI and the NRI indices, in terms of like biodiversity kind of richness and layers and things like that. But no, I think it would, I think it would be good to assess how those could potentially be layered in, especially as we start to kind of embed more, kind of like I showed the vulnerability layers and things like that, and can potentially pair that with some of the invest layers. And there's another pillar of this human development report that is going to be looking at kind of economic aspects of not only climate change, but sort of like the desire to decouple human development and HDI progress from things like emissions and whatnot. And there's some aspects that relate to natural capital that we're considering for that too. So it's a good flag.
I just mentioned this, and I brought this up at the very beginning. That model of extracting more value for humans from nature, which is ecosystem services, is one of them, is something I think that's easily fulfilled through your ordinary economic approach. What's missing is what we're trying to work on, right? What is it that we're actually doing that produces better conditions for the rest of life, right? We're getting better and better at extracting nature's services. Natural capital is something that we've been doing, I think, since the dawn of time. And it's time, I think, to at least for these larger scale societies that have really put the world into an extraction mode, to have something about giving back. And that's the focus here. We're not talking about nature's contributions to people, but rather people's contributions to nature. So it's a different framework. It doesn't mean that that you don't do nature's contributions to people. It just means that you do need something that's a little different as well. Can't just.
Okay, thanks, Earl. I think let's since we have time, let's shift towards a more interactive way. So let's if you have questions, just raise your hand and then we'll call on you and please unmute. The next question is from Maxime Chapelia from GTAP. Maxime.
Thank you, everyone. Thank you for very interesting presentations. I have a question regarding the way kind of risks are represented. I was wondering whether you account in any way for socioeconomic and market conditions and market-mediated responses to risks when evaluating the index itself? Because obviously, different economic, for instance, conditions would imply that yield impacts from climate change in US would be very differently kind of impactful and risky compared to the same yield impact, for instance, in Africa, right? So are you accounting for these second and third order conditions? And as number of earlier papers shows that these market-mediated responses in many cases play a major role, when comparing direct versus more indirect risks, even without direct adaptation measures, right? So we are not talking here about specific adaptation measure, but more like market-embedded measures. So I was wondering, how do you account that when you construct the index? Thank you.
Yeah, thanks for that question. No, it's a good point, and I think it gets into that kind of like three-part Venn diagram type matrix around risk that I talked about, and that the bulk of our attention thus far has really just been looking at compound exposure patterns, and then we're starting to layer in some of these relative kind of deprivation things, but the market conditions, and so some of the socioeconomic conditions are sort of represented by proxy in some of these global vulnerability layers. But in terms of market conditions and market responses, that gets at some elements of kind of like relative sensitivity to the same hazard. So if one country is exposed to the same category hurricane, but it is much less resilient, or it doesn't have market buffers or different sort of safeguards, regardless of like kind of like longer term adaptation, obviously the impacts are going to be very different. And so one of the things that we're looking at potentially embedding further down the line as well is kind of for each of these climate hazards that we're looking at, what does the literature show in terms of like damage functions by location for each of these. So like exposure to the same wind speeds from a tropical cyclone in country X versus country Y. What are the anticipated mortality impacts of that? And so part of the challenge is that there's not necessarily comprehensive, globally varying like causal econometric studies that tease out exactly what each damage function is going to look like for every hazard at every location. But there are some pretty good ones, like for sort of mortality response to temperature rises, and that varies widely around different regions of the world, especially depending on adaptation and some of the market conditions that you mentioned. So part of it, I think the answer is like yes. I think it's a very relevant aspect to include, but part of the challenge is again trying to like capture that balance between something that is interpretable versus overly complex. And so once we start to layer in a lot more of these different layers of sensitivity and adaptive capacity and market conditions, then the index itself starts to get a little bit harder to explain overall. So we're trying to like probably produce a few versions of the index, one that's going to be just sort of exposure to compound risk, and then one that will start to include some of these other things. But yeah, it's a good point.
Can
Thanks.
I just add briefly, Maxime, great question, and I think it's central to the idea of human development, because human development is not only about this broader notion of well-being that we capture in the Human Development Index, but also recognizing that people have agency, right? People are not passive and are just going to take on these hits and not do anything to respond to them. So I think this is something very important. Now, in the work that Nick is doing, we don't have an explicit way of modeling adaptation, as Nick alluded to. So we're focusing more on the hazard and exposure. And in that later slides that Nick showed, we're trying to sort of have a multiplicative approach to just get to a broader notion of risk that accounts to the potential for people to adapt by simply multiplying the index of exposure to hazards with social economic conditions, essentially. So it gets there, but it's imperfect. Now, where we have done a bit more systematic studies in the Nature paper that I put on the chat that relates to the impact on agricultural yields of climate change. So that paper and the estimates that we have in our Human Climate Horizons platform do account for adaptation. So what the model suggests is that even accounting for adaptation, you would have, adaptation would basically reduces the damages by about a quarter by 2050 and by about a third by the end of the century. So you still have a lot of residual effort on the basis of sort of optimal adaptation policies as modeled in the paper. Different for some crops like rice. I think when it comes to rice, adaptation can do much more. So this is something that is central to the thinking that we are doing, even though in both of the indices that we are focusing on today, it's not something that we are explicitly modeling.
Okay.
You see this paper that I put on agricultural yields, Maxime, on the chat?
Yeah. Thank you.
Okay.
Yeah. Just maybe
I know that
quick reaction.
Sorry, Tom has done also some important work on this that we probably should use potentially, and GTAP more broadly.
Yeah, would be just interesting, to run impact channels essentially that you presented through, for instance, GTAP or other TGE models and see essentially direct versus indirect impacts, just to compare whether even the distribution of damages across countries and vulnerability would change.
Okay, thanks, Maxime.
Can we take this idea forward, Maxime's idea forward? I mean, how would we go about doing that, Maxime?
So, I mean, we already done some work in this area for climate impacts, for instance, on yield, labor, heat stress, livestock productivity, number of other channels. So the idea would be to parameterize the shocks that you have estimated, for instance, in your index across dimensions that you presented, 6 dimensions. Not sure if we will be able to parameterize all of them, but at least some of them, obviously, yields the easiest one. But I suppose some other damages, like for instance, from climate events, should be also relatively easy to parameterize. And then we can just implement those as shocks in our models. So we have dynamic models. We can match the time horizons that you have presented, for instance, till 2100 or 2070. And then, so the first option could be to run that through the models, see what models suggest in terms of country impacts, sectoral impacts, and compare the distribution of impacts, country vulnerabilities to the vulnerabilities that you are estimating in the index, right? Which would be, in the index, it's just like first order impacts, and in the model, it would be first order plus all other kind of order impacts. And then potentially we can make one step forward doing some type of decomposition analysis where we turn on and off some of the market-mediated adaptation channels available in the model, for instance, trade channel. So we can assume, for instance, that the trade adjustments, elasticities are close to zero, so essentially not present, see what is the impact of that channel. Resource allocation, right? So we can try and play around with adaptation channels and do additional decomposition, right?
I think that would be very exciting. And I think it would provide that link to policy, right? So if you lose trade as a tool to ensure, essentially, right? What would be the outcome? So maybe we can take that offline with maybe with Nick and see if we can. Is that okay?
Definitely. That'd be interesting.
Yeah, I'm happy to follow up on this if helpful. So
wonderful. Thanks, Maxime.
Thank you.
Thank you. Any more questions? Well, while we're waiting for questions, I was going into that direction as well. So I think most of those who are in this call from the GTAP network would like to get hold of the data or the indices at different levels, right? So for most of those who are in the GTAP network, they're interested at the global level, and for those who are in the GlassNet, led by Tom, they would want to go into the grid cell level. So my question is, are the indices available at all levels that you presented? Will they become publicly available at some point so that they can be coupled with either the GTAP model or the simple G model, which operates at finer grid cell levels?
Definitely, Erwin. Everything that we do is going to be made available publicly and with all the details available publicly. I just need to check with Nick because some of the data I believe might be proprietary on drought, particularly. I don't know if drought is the one where we are having more trouble, but ultimately
No, yeah.
the idea is to make everything publicly available.
Mhm. Yeah, some of the tropical cyclone data we use are proprietary, but they're provided in such a way that yeah, we can likely provide it if it's aggregated in the way that we're doing and combined with in this, and it's like kind of just relative exposure. So we can talk about that, but
Okay. Any more questions? Well, I think one last for me. Are you also relating this to some sort of planetary boundaries or nature's frontier, which have been circulated the last few years or so?
I'll let maybe Earl elaborate, but the idea, as I mentioned in the beginning, is to offer something that sort of supplements that notion that we are facing constraints, and there are different reasons to do this. One is that any narrative around tipping points, which the planetary boundaries implicit suggest that if you reach some sort of tipping point, then these very bad outcomes occur. If you have uncertainty around the threshold, that actually does not incentivize people to cooperate. And you can understand this with a very simple game theory model. If there is a certainty on the threshold, nobody wants to be on the wrong side of the action, right? You don't want to be the one blamed for tipping over the edge. But if there's uncertainty around the threshold, then you have less incentive to contribute, because who knows if the action that you're going to take matters or not. And there's experimental evidence that this is actually the way in which people respond in experiments. So the work of Scott Barrett is an example of some of these kind of studies. So I think the argument, it's a more technical argument to suggest that relying on these framings with the assumption that this is going to mobilize collective action and leads to the mobilization of the public and of policymakers towards cooperation is not as promising as many people sometimes assume. And so that's why we are not saying don't do the planetary boundaries. I think it has its role, and it played an important role in mobilizing many people, but it also alienates others, right? And it also is perhaps facing decreasing returns in terms of mobilizing action. I mean, we just look at the data and we see that greenhouse gas emissions continue to grow, and so the assumption about certainly the NRI is that we need to supplement those narratives with something that is a little bit more aspirational and positive. Earl, I don't know if you want to complement.
Well, I'll go a little bit further than that on two fronts. The uncritical use of planetary boundaries is an example of, I think, scientific misconduct. The idea that these boundaries are determined scientifically, or even could be, is problematic and actually not correct, right? Boundary setting of the type that you see in the planetary boundaries. For example, the consequences of setting a boundary for synthetic nitrogen. The whole idea that you could set a boundary somehow through some kind of objective monitoring of the Earth system or modeling of the Earth system it hasn't been done. Merely a small group of experts, unselected by any political group, right? This is something that's going to affect every country in the world with a significant consequence, right? The synthetic nitrogen is fundamentally important for sustaining people today. The idea that there is this boundary is just that, and the use of this kind of boundary uncritically, and I think you can do that with all the boundaries. You just take a closer look at them scientifically, and you can see that these are not even possibly set by science. They're set by a group of individuals who made some choices. And I think those choices are not up to a small group of experts in Stockholm. It really is something that needs to be set through a process. The best thing about the Paris Agreement is that it represents an international agreement. It's an effort to come together to do something about a challenge faced by nations around the world. That's what makes it useful. But as we've seen, even the act of setting a boundary, especially one that was set for the purposes of creating a crisis narrative, right? The idea that we're imminently facing this boundary that once we cross it will cause unknown tolls. This is currently playing out, and we can see how this boundary setting approach isn't necessarily the most motivating. It isn't necessarily the one that will lead to action to actually change things for the better. And so those two elements, the idea that we should think about planetary challenges in terms of crossing simple boundaries and targets, is problematic and creates a lot, maybe more problems than it solves. And then the other, of course, is how do you set these things? Can they actually be set by a small group of scientists, or are they something that requires a negotiation among the stakeholders involved? And I would argue that the planetary boundaries cannot be set by science. They need to be set. If you're going to set these kinds of boundaries, they should be through international agreement, not through a small group of experts. So I would make both of those criticisms of that.
Perfect. Thanks. Thank you, Nick. All right. Well, if there are no other questions or reactions, I think we're now moving towards closing this webinar. On behalf of everyone at GTAP and the whole GTAP network, we would like to thank you, Pedro, Nick, and Earl, for this amazing initiative and research work. I think everyone at GTAP would at some point like to get hold of the indices at different levels and would like to use it to couple with the GTAP model or their GTAP related analysis. So we look forward to accessing all the indices sometime May next year, and we very much look forward to reading the 2026 HDR. Thank you so much, everyone, for joining the webinar, and enjoy the rest of the day, evening, or have a good night.